Hey everyone, and welcome to section 2.7. We're skipping section 2.6, so this is directly following 2.5. In 2.5, we talked about how to solve linear inequalities, and in this section, we're going to be throwing absolute value signs in there. Remember that the absolute value of a number, c, written as denoted, is defined in this way. It is the number itself if c is 0 or positive, and it is the opposite if c is negative. But since we know about inequalities now, we can give ourselves a sophistication upgrade, which is to say that we can also write the absolute value of c this way. It's saying the exact same thing, but in slightly more chic terms. So here we have the absolute value of x equals 4. So based on this definition, there's really only two things that x could be. X could be 4, or x could be negative 4. Because when I take the absolute values of both of those numbers, I get 4. So as far as solutions are concerned, there's two of them. So we're going to beat this point to death a little bit. Absolute value of x equals 8. Either x is equal to 8 or it's equal to negative 8. Those are the only two possibilities. Absolute value of y is equal to negative 2. This equation has no solutions. And the reason it has no solutions is because the absolute value of anything is always greater than or equal to 0. What about absolute value of z equals 0? Well, there's only one number it could be. So these are pretty much the three outcomes you could see. Either you get two solutions, you have no solution, or you just have one solution in the event that you have something like absolute value equals 0. All right, and here we have the absolute value of x minus 3 equals 2. This is a little bit different because there's actually something going on inside the absolute value of the variable. But we can take the approach that we used here and adapt it. Because the absolute value of something is equal to 2, then that something has to be either 2 or negative 2. But these are super easy equations to solve. And so again, we end up with two equations, two solutions like we did in part A. But since there was something else going on inside the absolute value, the solutions don't end up being opposites. So that's a possibility. All right, in general, to solve absolute value equations, first of all, you want to get the absolute value expression by itself. Then you want to write down the equivalent equations. If it happens to be that you have the absolute value of something equals 0, then you only have one equation. But otherwise, there's going to be two. solve the equations, and then check your solutions. So again, basically working the same way as what we did in section 2.1, which is solving linear equations in one unknown. So for an example, we have 2 times the absolute value of x minus 7 plus 5 equals 9. I want to get the absolute value expression by itself. So I'm going to subtract 5 from both sides. And that gives me 2 times the absolute value of x minus 7 equals 4. Now what I'm going to do is divide by the coefficient of the absolute value. So we end up with x minus 7 equals 2. And now we get 2 equations, which again are pretty easy to solve. And let's graph them. So here's 5. Let's pretend 9 is right here. To check, we're going to plug both of our answers in and simplify. Okay, so for x equals 9, we get 9 like we're supposed to. The absolute value of negative 2 is 2. So we get 9 again. Next up, we come out swinging by subtracting 11 from both sides. Which brings us to the absolute value of 2/3 x minus 4 equals negative 8. And hey, we have a negative, but we know that the absolute value of something is always greater than or equal to 0. What does this mean? There are no solutions. That is, there is no value of x satisfying that equation. And finally, we have absolute value of x minus 3 equals the absolute value of 2x plus 1. This is a little bit strange because we have absolute values on both sides, but it works pretty much the same way. When we have 2 absolute values, either x minus 3 is equal to 2x plus 1, or it's equal to the negative of 2x plus 1. And be mindful of your negative signs. Watch out. It's the opposite of the number 2x plus 1, which means you're going to have to take this negative sign and distribute it, which is really multiplying by negative 1. So on the equation on the right, after distributing the negative sign, we get x minus 3 equals negative 2x minus 1. Standard procedure from here. So one of our solutions is x equals 2 over 3. Let's do the other one. And the other solution is x equals -4. So there are our two solutions graphed on the number line. And we'll do a quick check. And the way that we're checking is we're substituting x on both sides of the equation. Don't forget that we treat the absolute value like a grouping symbol, and we have to follow order of operations inside. We'll check the second solution. And both of our solutions work. So that's it for this video. Next up, we're going to be looking at solving absolute value inequalities instead of equations.